Alright, so what we're going to do today is we're going to talk about cosine. So cosine of theta looks a lot like sine of theta. Okay, so I want to review, we did sine of theta yesterday, but I just want to review a few things. For example, we always start at the terminal side, and on the unit circle we start here, which is the point 1, 0. Now, what's the relationship between the x and y coordinate points or values with regards to sine and cosine? Well, cosine of theta, if I were to draw my right triangle, the adjacent over the hypotenuse is really the x-coordinate over the radius. But on the unit circle, the radius is 1. So what I end up with is cosine of theta on the unit circle is just x. Okay? And so I'm going to move this over here, down here, so it's kind of out of the way as best I can. Yeah, we'll move that down there too. So it's really just x. In fact, we said that yesterday. So when we think of the points on the unit circle, think of them in terms of cosine of theta, sine of theta. And on the unit circle, I have 4 points in particular, although I have many points on the circle. But of those 4 points, this one is going to be 0, 1. This one's going to be -1, 0. And then this one will be 0, -1. And I'm just going to go through and underline all of the cosines. So this is cosine, this is cosine, this is cosine, this is cosine. And so since we're starting from the terminal side here, what angle is this at the terminal side in radians? Right here. Here, theta is equal to 0 radians, right? Now, if I rotate around this way, actually, I wanted that in red. If I rotate around that way, what angle is this in radians? Well, that's just theta is equal to pi over 2. And so if I graph these points, I'm going to say that the y-axis is going to represent sine of theta, and this axis represents theta. And so the way this is going to work is that every point on this graph is going to be theta, I'm sorry, not sine of theta, cosine of theta, right? We're doing cosine today. This is cosine. So it's going to be sine, cosine of theta. And that's a numerical value, right? So here's the confusing part. I've got theta, cosine of theta. We're used to seeing x's and y's, but we have x's and y's on the unit circle. So here's what I want you guys to keep in mind. Okay? Right here, what is theta? 0, right? And what is cosine of theta? 1. Okay? So we're going to graph 0, 1, and I'm gonna exaggerate this just a little bit. So this is 1. So this point right here is the point 0, 1. Now what that really is it is theta in radians, cosine of theta. Now we're going to move to the second point here. What is theta? Pi over 2. So I'm gonna say pi over 2 is right here. What is cosine of theta? 0. So here I have the point pi over 2, comma, 0. Does that make sense? Now, if I rotate around from here to here, what is that in radians? Pi. So over here, I'm going to go to pi, which is twice pi over 2, which will be right here. But now I'm going to come, what is my cosine value on the unit circle? Underlined in green. You guys are like, it's -1. So I'm going to come down right here. This is like -1. So we'll say that that's -1 and this is 1. So I'm going to come down here, right here, at pi -1. Now that is going to be pi, comma, -1 on your calculator if we graph it in radian mode. Okay? Now if I rotate, starting at the terminal side, and I come around this way, all the way to here, what is this angle in radian mode? 3 pi over 2. Okay? So 3 pi over 2, this is 1 pi over 2, 2 pi over 2. It's going to be right here, 3 pi over 2. But what is my corresponding cosine value on the unit circle? Underlined in green. 0. So this is a point here. In fact, I'm going to take all my points and make them red. So I've got this point here, this point here, this point here, this point here. And so that one is 3 pi over 2, comma, 0. Now, we're almost done. If I take and start at the terminal side here, and I come all the way around, what's my cosine value? 1. What is my degree in radian, or not degree, what is my angle in radians? 2 pi, right? So theta for this is equal to 2 pi, which is the same as 4 pi over 2. So that's going to come here, but it's going to be at 1. All right? So I'm going to clean this up a little bit, just so you guys can kind of see that at 2 pi, this ends up right back here at 1. Does that make sense? Now, if I come through here, it looks like this. Does that make sense to you guys? Now, you said, well, that sort of looks like sine. Let's get rid of all this stuff. What happens if I go from here to here? What angle is that? Here, theta is equal to negative pi over 2, because we're going in the negative direction, right? This way is positive direction. This way is the negative direction. Whoops. What is this point right here? 0, comma, -1. Which one are we interested in? Well, for cosine, this, right? Why? Because on the unit circle, cosine of theta is equal to x. So, if I go negative pi over 2, comma, 0. What do you think happens if I continue to come around from here to here? And from here to here? And then lastly, from here to here. Well, it's symmetrical about the y-axis, so I'm going to end up with these points here. I'm going to end up with this point here, and then this point here. Whoops, I got my point wrong. And so you kind of get like this. Okay? Any questions so far? All right, so that's what my graph looks like. So now let's graph it on a graphing calculator and take a look-see. So if I come here and I clear this out and I put cosine of x, and I want to make sure that I'm in radian mode, so I'm going to hit mode. I'm in radian mode, and then there's a really cool thing. There's one called Z-Trig that's a setup in your zoom. It automatically zooms nice and neat for trig functions. It goes like negative 2 pi to 2 pi in the x directions. And then y, it goes like, I don't know, it's like negative 5 and 5. I can't remember exactly what it is, but it's perfect for trig function. And so this is what cosine looks like. Okay? That's what cosine looks like. Now what I'm going to do is, just for fun, let's graph sine here and see how they look together. The blue one's cosine, the red one is sine. So they're very similar. In fact, they're almost identical. It's just one is actually shifted over, pi over 2. And that's just because, well, the numbers are the same, right? On the unit circle, you've got 0, 1, negative 1, 0, the way that it goes. But one is the x value, one is the y value. So let's turn off sine. So based on this graph, I want to ask you guys some questions, okay? What's the domain of this graph? Oops, I thought I turned off sine. I guess I didn't. All right, there we go. What's the domain of cosine of x? Yes?
All reals.
All reals. You know, Mr. Adams, if you guys are tired of writing like all reals, you could just draw an R with like a line through it like that. That means the same thing, all real numbers. Anybody want to take a stab at what the range of this thing is? What's the range? Yes? Negative 1 to 1? Somebody already shouted it out. Negative 1 to 1. If you wanted to guess, what do you think the period of this thing would be? Yeah, it's 2 pi like sine, but it looks a little different. So technically, it starts here and goes from here. So this is like 0 to 2 pi. But if you notice, that's when the pattern repeats. And we'll talk about that in either the next section or the section after that. We'll talk about identifying periodic behavior in graphs. But basically, an informal way to think of that is when the graph repeats itself, right? What else do we know about that? Is there anything else that we know? There's one last thing. If I were to take this and put a mirror there, what do you, yeah, I see a hand up. Symmetrical about the y-axis. So if it's symmetrical about the y-axis, whoops, I misspelled the word about. I really need help. I didn't have coffee this morning. About y-axis. If something's symmetrical about the y-axis, what type of function is it? Even. Good. So it's an even function. this is very helpful later on down the road. Okay? Are any of you guys interested in being engineers? Anyone in this class? Anybody? No one? Anybody thinking about being electricians? No? Well, if you were, that would be important. It's still important to the rest of you because I'm going to give you a test on it. So, but we use this a lot to kind of cheat in math. Sometimes we can't always take the negative of theta, so we use that property to kind of cheat. We use that for some of the trig identities too. So anyways, that's it. Does anybody have any questions on that? All right.